So in the last video, we sort of abruptly ended right after defining S3. And so S3 is this group, and we saw that it was a group, and we saw that it can be written in terms of these elements x and y, where x is this permutation of a triangle that leaves the vertices looking like this, with 1 here, 2 here, and 3 there. If this is our original triangle. And y is this sort of reflection here. X is more of a rotation. And so what we'd like to do is find some sort of relations between the elements x and y that will be enough to describe the group S3 entirely. And the process of sort of finding these relations is sort of a hard one. I have them written down here, and we're just going to sort of see what they mean in the context of S3. So for starters, we can see that x cubed is equal to 1. How is x cubed equal to 1? Well, if I rotate once, and then I rotate again, and then I rotate again, clearly I should have what I came with, because this is a triangle. I've rotated it 3 times. I should get back the same thing. Also, if you think about this reflection right here, I flip it once, it's flipped. I flip it back the second time, and then it'll get back just what I started with. So that means that I can also write down y squared equals 1. And this final relation, I think, might be a little bit hard to come up with just on the fly, but it is actually enough, along with these two right here, to describe the group S3 entirely. And we'll talk later about what this means. So the relation is yx equals x squared y. And so let's look at both sides of this equation and see what this means. So first of all, when we're applying these sort of symmetries, we start from the right. First, we apply the thing on the right, and then we go this way. We go towards the left. So let's evaluate both sides of this equal sign and confirm that this relation holds in S3. All right, so for starters, yx equals, okay, so first let's start by applying x. So to apply x, we've got to rotate the vertices around. So we'll rotate them, rotate, rotate. So we now have what it looks like after just applying x. Now we need to apply y. Y flips these bottom two vertices here. So what we'll do is we'll take these 1 and 3 now instead of 1 and 2 and flip them. And we're left with 1, 2, 3. So I'm going to write this triangle down here. 1, 2, 3. Now let's check the other side. X squared y. So if I go back to my original triangle, which had 1 here, which had 2 here, and which had 3 there, what I'm now going to do is I'm now going to first apply y. So the way I'm going to apply y is by reflecting right here. I'm going to flip these two. So I've got these, put them over there. And now I'm going to apply x squared, which means I'm going to apply x twice, which means I'm going to rotate twice. So I'll rotate once. Maybe I'll rotate everything once. Rotation. Come on, little 3. You can do it. Yeah, there we go. So I've rotated once, and now I'll rotate once more. 1. And I'm left with what turns out to be the exact same triangle. 1 on this side, 3 on this side, and 2 on the top. So these three equations here, they're called the relations of S3, and they are what we are going to use in order to think about S3 as we continue with our examples.